So one application of an absolute value inequality is the concept of the unfair coin. I'm reading this on purpose because I tend to make mistakes on this one if I don't. If a coin is tossed 100 times, we would expect approximately 50 of the tosses to be heads. However, it's rarely the case that you hit exactly 50. So there's some kind of scientific way to show that you can be a little off of 50 and still considered a fair coin. And yeah, I'll keep reading. Toss a coin 100 times to test this hypothesis. I think it's a little bit out of order for the one you guys have, but it's still the same stuff. So record the number of times that the coin is heads and the number of times the coin is tails on the line below. You may want to ask someone to tally the results of the tosses for you. Well, let's pretend that I'm tossing coins, and behold, I've tossed, say, 54 heads. And if I toss 54 heads, that means that I tossed also 46 tails. Okay, so yeah, I was tossing pretty hard over here, pretty quick. And I'm just going to leave that part alone for now. Okay, we'll come back to those numbers here in a second. But then it says, a coin is considered an unfair coin if H, that's the number of heads that's tossed into this inequality right here, the number of outcomes that results in heads, satisfies this. So if this is a true inequality, it's an unfair coin. So be careful, because students in the past have interpreted this inequality as though it would give us fairness. But by the time we solve it, hopefully it will make sense that it is not. Now, we've seen an inequality, an absolute value application like this, but it was an equation. This one's an inequality, but all the standard rules apply for solving this one, even though it's got a decimal and a fraction, all right? So we are going to split this up into two separate inequalities, right? I got h minus 50 all over 5, and again, I start with the positive, so it equals, greater than or equal to 6.45. And then on the other hand, we got that h minus 50 over 5, but this time we flip the inequality and then compare it to its negative 1.645. I just kind of struggled for space at the end there. But yeah, we're going to solve this just like we would going forward with regular inequality. We get to solve it twice. It's so much more fun. So yeah, multiply both sides by 5 now. And this is where I'm going to need my calculator. So I got h minus 50 is greater than or equal to, where did my calculator go? There it is. So 1.645 times 5, 8.225. So we'll write that in, 8.225. And yeah, if you did it on this other one as well, right? Multiply this one by 5, and then over here you're going to multiply that by 5. You have the same values, it's just this one's negative. So h minus 50, yeah, these cancel down to 5s. It's less than or equal to negative 8.225. Well, from here, I covered it with my calculator. There we go. Yeah, just add 50 to both sides, right? On both of them, actually. And this first one, the addition's not too bad. Just h is greater than or equal to 58.225. Now, the assignment up above said round this to the nearest whole toss, I guess. Maybe not worded exactly like that, but we're just going to say 58. Okay, so again, just interpreting this. I know we haven't solved this one on the right, but we're going to. Interpretation of this would say if you toss 58 or more heads, then your coin is not fair, because it would make it true, right? Well, let's go to the other one and see what we get. So we're still going to add 50 to this. So plus 50 to both sides, and h now, it could be less than or equal to, let's see what this is on the calculator. So now I got negative, get my negative in there, 8.225 minus, plus, where's my delete, plus 50, 41.775. And again, we'll just round this to the nearest whole toss. So even though, 42 rounded up, it wouldn't necessarily be included in the set. Just by the rounding, we're just going to keep it as is, okay? Now, up there, it was eating the absolute value. So this is an OR statement, by the way. And again, it's an OR statement for unfairness of the coin. So interpreting this one on the right, the orange stuff, it's saying that if you toss 42 or less heads out of 100 tosses, then it's an unfair coin. All right. All right. So that solves the inequality. That was part 2A. What values of H will tell us we have an unfair coin if the coin is tossed 100 times. We showed our work in the space below, but then so that solved the absolute value inequality. We rounded to the nearest whole number. That's what I was talking about before. But then it says the graph, the solutions. So I'll put the graph above, I guess a little bit to the right. We shouldn't need much more space in that. And we're dealing with, right there, that's where 0 would be, 58 would be way to the right, and then 42 somewhere over here. And again, it's not proportional. It doesn't have to be, though. So for 58, it could be equal to 58, so I get a closed circle there. It's eating the H, so it goes to the right. 42, same thing. It's equal to 42, so I get a closed circle there. It's not eating the H, so it goes to the left. Now, if you want to be super technical about this, not that I really care, or that you should care about it, because you'll go into it in more detail in 10.10. But if you're like, you can't go to the left of 0 because you can't have negative tosses, that's true. And if you wanted to write the interval that way, you could. Or you could say, on the other hand, with the green side of things, you could say, well, you're not tossing it more than 100 times, so it only goes from 58 to 100. Okay, that's fine. But I'm not going to do it that way. I'm just going to show it like we've been talking about, even though that analysis is correct and it's good. It's just a little bit more ambitious than I need to be right now. So we're going to show this as going from negative infinity, stopping at 42, which is included. And then, we're going to unite it with the green, which starts at 58. And I'm trying to write that a little bit smaller to squeeze this in. Going to infinity, that's the interval. So that takes care of part B and C on question 2 there. But then it says, write a sentence that explains the solution to this inequality. We can do that. I'll try to put it here on the right because I got a little bit of space there, So, just like we said before, we actually already described it verbally, but let's go ahead and put this in words, all right? So, you can start with the 58 or 42. It's just, again, I'll say if you were to toss 58 or more heads, and I'll kind of emphasize the or on this, or 42, right? 42 or less heads, then your coin, and again, this goes back to the first part, the coin is unfair. All of those would make it true. Then it's an unfair. Then your coin, is unfair. That'd be better. Is unfair. Bam. There we go. We did it. And that wasn't too much writing for this. But so that's question 3. But question 4 for me says, based on this solution interval from problem 2, which we have right there in orange and green, have you been tossing a fair or unfair coin? Well, let's further interpret this, okay? That means that from 42 to 58, as soon as you toss 43 or even 57 heads, then it is a fair coin, right? Now, we tossed 54, which on this number line would show up, about right here, which means it's also in between the 42 and 58 part, which means it makes the original inequality false, which means that everything between 42 and 58 is the fair interval of things. So yeah, that the 54 fits in the fair range of tosses of heads for this coin. So based on a solution, we got to explain it. So yeah, I'll put the sentence on that for us, because writing in math is, it's a joy. So we tossed, or I tossed, doesn't matter. What did I say? 56? Yeah, 54. There we go. 54 heads. So my coin is in the fair range and is a fair coin. Maybe that was a little redundant again, but hopefully it drives the point home.